To measure the size of the planet, the Greeks needed two cities, a long journey between them, and a careful comparison of the sun's angle at each. That method had stood for more than 1,000 years. Then, a scholar from Khwarezm, in what is now western Uzbekistan, worked out how to do it from one location in a single afternoon using a hill and an astrolabe. He climbed to the top, waited for a clear day, and measured the tiny angle by which the horizon appears to sink below true level when viewed from a height. That angle, combined with the height of the hill, is enough. His answer came within a small margin of the figure satellites give today. His name was Abu Rayhan Al-Biruni, and the Earth's radius was one of the smaller problems he solved. He was born in September 973 in the outskirts of Kath, a city of Khwarezm on the lower Amu Darya, in the region that is now Karakalpakstan. The name by which he is known derives from a word meaning the outer district, indicating that he came from outside the city proper. He received a mathematical and astronomical education under a member of the local ruling house, and he was making recorded astronomical observations before he was 20. His early adulthood coincided with the political collapse of his homeland. Khwarezm was fought over, the ruling family he depended on was destroyed, and Al-Biruni spent years moving between patrons in the Caspian region and Central Asia. He returned to Khwarezm under a later ruler, and in 1017 Mahmud of Ghazni conquered the region and brought the scholars of the court, Al-Biruni among them, back to Ghazna. He remained attached to the Ghaznavid court for the rest of his life and died around 1048. The volume of his output is documented in a list he compiled himself. He recorded around 146 titles, of which fewer than a quarter survive. The surviving works alone establish him as one of the most wide-ranging scientific minds of the pre-modern world. His first major book, completed around 1000, is The Chronology of Ancient Nations. It is a comparative study of the calendar systems, eras, and festivals of the Persians, Greeks, Jews, Christians, Arabs, and others. To write it, he had to reconstruct how each civilization counted time, reconcile the systems mathematically, and assess the reliability of the sources describing them. The method he used, comparing accounts, weighing the credibility of informants, and separating what is documented from what is asserted, is the reason he is frequently described as one of the earliest practitioners of the comparative study of religion and of critical historical method. The measurement of the Earth appears in a later work on geographical coordinates. The technique required him to first determine the height of a hill by taking sightings from 2 points a known distance apart, then to climb it and measure the dip of the horizon. Historians who have examined the calculation note that the accuracy depended on precise trigonometric tables, which he had access to partly through Indian mathematical sources, and that he had no means of correcting for atmospheric refraction, which affects the result. Even allowing for that, the figure he produced sits close to the modern value, and the method itself, requiring one location rather than 2 cities and a survey party, was a genuine advance. The reason he had access to Indian sources brings us to his most remarkable book. When the Ghaznavid campaigns opened routes into northern India, Al-Biruni went and stayed for extended periods. He learned Sanskrit. He read Indian astronomical and mathematical texts in the original. He talked to Brahmin scholars. And around 1030 he produced Kitab al-Hind, an account of Indian religion, philosophy, science, literature, law, and custom, written for readers who knew nothing about the subcontinent. What distinguishes the book is its stated method. Al-Biruni set out to record what Indian scholars themselves believed, in their own terms, rather than what outsiders said about them. He translated Sanskrit works into Arabic and Arabic works into Sanskrit. He compared Indian philosophical positions with Greek ones and noted where they agreed. He was explicit about the difficulty of the task, about the barriers of language and religious difference, and about the errors introduced when a writer relies on hearsay. Modern scholars of South Asia still use the book as a source for 11th century Indian intellectual life, which is an unusual thing to be able to say about a work written 1,000 years ago by a foreign visitor. His astronomical work is equally substantial. His major treatise, the Masudic Canon, dedicated to the Ghaznavid ruler Masud, is a comprehensive work of mathematical astronomy covering trigonometry, the motions of the planets, geography, and the calculation of coordinates. He determined latitudes and longitudes for a large number of cities, developed methods for finding the direction of Mecca from any location, and produced a systematic treatment of what would later be called spherical trigonometry. He also engaged in a documented scientific correspondence with Ibn Sina, who was roughly 7 years younger and working in the same region. The exchange survives. Al-Biruni put a series of questions challenging positions in Aristotle's physics and cosmology, including whether the heavens could contain other worlds, why celestial motion should be circular, and problems concerning heat, vision, and the nature of space. Ibn Sina answered, defending the Aristotelian framework. Al-Biruni pressed further. The tone in places is sharp. What the correspondence records is two of the most capable minds of the 11th century, both from Central Asia, disagreeing in writing about the structure of the physical universe. Other results scattered through his work have attracted particular attention from historians of science. He measured the specific gravity of a range of metals and precious stones with an accuracy that was not improved upon for centuries. He described the operation of natural springs and artesian wells through the principle of communicating vessels. He examined the geological evidence of the Indus Valley and concluded that the plain had been formed from deposits laid down by water over a very long period, and that the region had once been a sea. He discussed the possibility that the Earth rotates on its own axis and set out the arguments on both sides, noting that the astronomical observations available to him could not settle the question either way. His interest in instruments was practical as well as theoretical. He wrote a treatise on the astrolabe and described modifications and variant designs, including a device with a geared mechanism for displaying the phases of the moon and the positions of the sun and moon in the zodiac. Surviving examples of geared calendar instruments from the medieval Islamic world are extremely rare, and his written description is one of the principal pieces of evidence that such mechanisms were being built at all. He also composed a long study devoted entirely to shadows, covering the geometry of gnomons, the construction of sundials, the determination of prayer times, and the trigonometric functions involved, which remains one of the fullest treatments of the period. Cartography occupied him as well. Determining the coordinates of cities was not an abstract exercise. It was the necessary groundwork for accurate maps and for the calculation of the direction of prayer from any point on Earth. He examined the mathematical problem of projecting a curved surface onto a flat one and discussed the distortions that different approaches introduce. He also compiled measurements of distances between cities across a vast area, cross-checking travelers' reports against astronomical determinations and flagging the cases where the two disagreed. Late in his life, he produced a substantial work on pharmacology, listing medicinal substances with their names in several languages, including Arabic, Persian, Greek, Syriac, and Sanskrit. The multilingual apparatus reflects the same concern visible throughout his career, that a term used in one tradition may not correspond exactly to a term used in another, and that a scholar who assumes equivalence without checking will introduce errors that later readers cannot detect. Histories of medicine have used the work to trace how drug knowledge moved between India, Iran, and the Mediterranean world. That last point is characteristic. Across his writing, Al-Biruni is unusually careful about the limits of what the evidence supports. He states which figures rest on his own observation and which he has taken from others. He records where his instruments were inadequate. He notes where a question cannot be decided with the data available. This is a habit of mind that appears rarely in scientific writing of any era before the modern period. He died in Ghazna around 1048, in his mid-70s, still working. The manuscript record shows that his major books circulated widely in the Islamic world. The Chronology and Kitab al-Hind were both edited and translated into English by Edward Sackow in the 19th century, which brought them to the attention of European scholarship, and they have been in continuous scholarly use since. His reputation among later scholars rested on that combination of breadth and caution. He is one of the very few figures of the medieval world who worked at a high level in mathematics, astronomy, geography, mineralogy, pharmacology, history, and the comparative study of cultures, and who left behind enough surviving text for modern specialists in each of those fields to assess him independently. The assessments have been consistent. A crater on the moon carries his name. So does an asteroid. But the more concrete legacy is in the method. A scholar from the lower Amu Darya who insisted on measuring rather than assuming, on reading sources in the original rather than in summary, and on stating plainly where his own knowledge ran out. History isn't just the past, it's the record of how the present came to be. Comment below with the scientist or period of Central Asian history you would like covered next. If this kind of documented, source-based history speaks to you, consider liking and subscribing so more of it can reach you. This video uses AI-generated audio and visuals for educational purposes only.